Good morning, students. Good morning. So, last part. Chemical bonding and molecular structure. So today will be the last session related to this topic because other portions has been covered by the madam. Fine. So I think today it is less attendance, maybe because tomorrow exam is there. Now I was simply telling. So that's where we have the chemical bonding and molecular structure. So can any one of you tell me what we had discussed in the last class? Anyone? What we had discussed in the last class? Okay, yes, Pooja. So we have discussed about dipole moment. Very good. Symbolically we can mention it as mu. Now what do you mean by dipole moment? Dipole moment is nothing but lattice theory. What do you mean by lattice theory, Chidwan? Okay, that is related to salt. So dipole moment, that is charge into distance. Charge into distance between those charge. Okay. So naturally for charge unit is coulomb and for distance it is meter. So therefore dipole moment will be coulomb meter. Same way we have debye units. Same way we have the debye units, which is also meant for the dipole moment. Okay. Now 1 debye unit is equal to 3.33 into 10 to the power of minus 30 coulomb meter. Okay. Sir, lattice structure is mesh type. Yes, Manjunath, yes. It is a mesh type. That means we are making this one comparable to mesh type of structure. Okay. So that's why it is called as a lattice. We are comparing that one to the mesh type of structure. Okay, this is related to dipole moment. Then we have discussed with some examples. We have discussed with some examples where we have seen nitrogen trifluoride will be having less dipole moment compared to the ammonia. So Pooja, she is writing dipole moment is not applicable for the molecule having same elements. Yes, very good. Yes, Pooja, absolutely correct. Dipole moment is applicable only in those molecules where different types of elements are there, but along with that, where there is a difference in their electronegativity. Then we can see the dipole moment, when we can see the difference in their electronegativity. Okay? So therefore, whenever dipole moment is high, those type of covalent bond will be called as polar covalent bond. Please remember, they are called as polar covalent bond. Where dipole moment is high, those type of covalent bonds can be called as polar covalent bond because it will be having the two terminals, positive terminal and negative terminal. Therefore, it will be called as polar covalent bond. But those covalent bonds which are present in hydrogen, in chlorine, they are all called as non-polar. They are all called as non-polar covalent bonds. Okay? Because they don't have the polarity. They don't have the polarity. Therefore, they are called as non-polar covalent bonds. But when it comes to molecules like water, or to be more appropriate, if I take HCl and R, That's where I can see polarity in their bond. Therefore, it is called as polar covalent bond, where dipole moment will be present. All of you have understood? That's what we have discussed related to dipole moment. Then we have discussed about ionic compounds. Then we have discussed about the ionic compounds. When I am talking about ionic compound, how this ionic compound will be formed? Ionic compounds will be formed when electronegative element is going to interact with highly electropositive element. So what I mean to tell here is those elements which are present on the extreme left hand side, when it is going to interact with those elements which are present on the extreme right hand side, so at that time there will be formation of a ionic compound. For example, alkali metals with halogens, they will form the ionic compound, right? So why they are called as ionic compound? They are called as ionic compound due to the presence of ionic bond. Due to the presence of ionic bond. So what do you mean by ionic bond? It is the multiple electrostatic interactions. It is the multiple electrostatic interactions present between or among the ions in a crystal structure. That's where it is called as ionic bond. So what do you mean by ionic bond? So these are the multiple interactions present between or among the ions in a ionic crystal structure. For example, this Na plus, it will be having interaction with chloride of this layer, chloride of this layer, chloride of this layer, chloride of this layer. So one Na plus multiple interaction. Same logic for applicable for chloride also. There will be many number of sodium ions which will be surrounding the chloride. That's where it is ionic bond. All of you have understood? That's where we have the ionic bond. They will become bit stronger bond when they are all together, when they are present. They will be a bit strong interaction. But if I take one Na plus, one Cl minus, if I take one Na plus and one Cl minus, then it will be a weak interaction. It's an electrostatic interaction, which is an example for non-covalent bond, electrostatic interaction. So in this case it is electrostatic interaction, which is a non-covalent bond, which is an example for non-covalent bond. But when I am talking about a crystal, where multiple interactions will be there, then it is called as ionic bond. Together they are called as ionic bond. All of you have understood? So that's where we have the ionic compounds, which will be having ionic bond between the ions. So any doubts? That's what we have discussed in the last class. Now we will come to one of the important rule, which is called as Fajang's rule. Means important in the sense, based on this concept you can expect the question in your competitive exam. But no one will ask, explain the Fajang's rule. Okay, that one will not be there. So what is that Fajang's rule? Fajang's rule, it is applicable for the ionic compound. Fajang's rule, it is applicable for the ionic compound. All of us we know, for ionic compounds to get formed, there will be requirement of, or we should consider, ionization enthalpy, that is ability of element to donate the electron. Then there will be electron gain enthalpy, that is ability of element to take up the electron. Then we have the enthalpy for formation of lattice. Enthalpy for the formation of lattice. Formation of lattice, that is to form the crystal structure. So these are the three major factors which is going to decide the ionic compound stability. Okay? But along with that, we have one rule which is called as Fajang's rule, which talks about covalent character in an ionic bond. It talks about covalent character. It talks about the covalent character in a ionic compounds, in a ionic bond or ionic compounds. So that's what Fajang's rule talks about. So what do you mean by covalent character? Covalent character means it is related to increase in the interaction. For example, if I take Na plus Cl minus, okay? Same way, we will be having K plus Cl minus. Now the question here will be where electrostatic interaction will be high, in KCl or in NaCl. That will be the question. This is one simple example I have taken. So NaCl, KCl, two different compounds where interaction will be more, whether it is in KCl or NaCl. Both are having ionic interaction, that is electrostatic interaction. But still, where interaction will be more, that's what covalent character. As the interaction increases, we will tell that it is a increase in the covalent character in an ionic compound. All of you have understood? Any doubts? Okay? Any doubts in this? So that's where we have the covalent character in an ionic compound. Don't get confused. There will not be formation of a covalent bond. No. But there will be difference in interactions among the ions depending on the element. So that's what covalent character talks about. Okay? Now, very important one here is, first point related to Fajang's rule here is, as the difference in the ionic size increases, covalent character increases. Covalent character increases. All of you have understood? What is that first one? As the difference in the ionic size increases, covalent character will also increase. For example, when I am talking about ionic compound, there will be presence of cations and there will be presence of anions. Now, can any one of you tell me whether which will be larger ion, anion or cations? Which will be of larger size? Whose ionic radius will be high? Whether it is anion or whether it is cation? Anyone? Whose ionic radius will be high? Anion or cation? Okay. So Rohan and Dhanush, cations, the people are telling ionic radius will be high. Yes, good morning Dikshit. So which will be having larger ionic radius, cations or anions? All of you are wrong. No. It will be the anions which will be having larger ionic radius, because since they have taken the electron, they have got the negative charge. Electrons are dominating. So therefore ionic radius is going to increase. Right? Say for example, Na plus Cl minus, it will be of this size, Na plus will be of this size. In the beginning, sodium was of this much size. Now it has decreased because because there is a decrease in the ionic radius because of losing of the electron by the sodium. But in this case, in case of the anions, where electron has been taken, here electron has been removed, here electron has been taken, So chlorine was of this much size. Now its size has been increased. Right? Okay, still you are getting confused. So you can remember cat with positive. Another one automatically you can remember. Any one of the ion you can remember. You can go with positive with cat. Okay, positive with cat. Another one, no need to remember. It is understood. Fine. So cations will be having positive charge. So therefore, since there is a losing of electron, it will become smaller. Anions will be negatively charged. Since it is gaining the electron, it will be increasing in the size compared to original atom. All of you have understood? So that's what. As the difference in the ionic size increases, that means as the decrease in the cation size and as the increase in the anion size. That's what it talks about. Okay, no Rohan. You can remember as cat as negative. That's all. Okay, so cat as negative. Sorry, cat as positive. You see, even I thought cation is negative and told cation. Okay, fine. That's fine, Rohan. But you can remember cat, pussycat, which will be having positive charge. Okay, so that's where we have the cations and anions. All of you have understood? So that's what they are talking about. As the difference of these increases, Na plus Cl minus I have taken here. So as the difference increases, covalent character will increase because there will be more amount of negative and positive charges. More interaction will happen. Fine. So therefore covalent character increases. Any doubts in this? That's what the first point related to Fajang's rule. Okay. So difference in the ionic radius means what? Difference in the size of the cation and anion which are involved in that particular ionic compound. That's what the first statement. Any doubts in that? Okay. Any doubts? Then we will move to the next point. Next point here is same thing. It is related to first only. As the charge of cation increases, covalent character will also increase. Covalent character increases. So what do you mean by charge? See, for example, I have sodium. It will become Na plus. Okay? But if I take the neighboring element, like magnesium, magnesium is going to lose 2 electrons and it will become magnesium plus 2. It will become magnesium plus 2. So what I mean to tell here is there is an increase in the charge. There is an increase in the charge. So therefore magnesium chloride will have more covalent character compared to sodium chloride. Magnesium chloride will have more covalent character compared to sodium chloride because there is an increase in the charge. Naturally, there will be drastic decrease in the size also because there is an increase in the charge. All of you have understood? Any doubts? Any doubts? Okay. So that's another point. As the charge of cation increases, it's going to increase the covalent character of that particular ionic compound where that particular ions are present. All of you have understood? Okay. So hagadre last point here is transition metals. Transition metals will form ionic compounds with more covalent character, with more covalent character, compared to alkali and alkaline earth metals. Okay, so ionic compounds will form more ionic compound which will be having more covalent character compared to alkali and alkaline earth metals. That is because in case of the transition metals, there will be involvement of desumption. So due to that, it's going to have higher polarizing power. Due to that, it will be having higher polarizing power. So therefore, they will form the covalent ionic compound with more covalent character due to higher polarizing power. Means that they can hold more anions powerfully. That's what polarizing power talks about. They can hold the anions more strongly. That's what polarizing power talks about. Okay, due to the involvement of desumption. All of you have understood? Any doubts? So these are some of the points related to Fajang's rule. Any doubts with regard to this? This is related to Fajang's rule. Fine. So direct question on Fajang's rule, it may not be there, but related to this rule means concept, there will be some questions in your competitive exams, or by utilizing this concept you can give the answer for some of the questions. So shall we move to the next one? Okay, Rakesh. Okay, fine. Then we will move to the next one. That is VSEPR theory. Okay, so that is nothing but valence shell electron pair repulsion theory. Okay, valence shell electron pair repulsion theory, VSEPR theory. Sometimes short form whisper theory they will tell. Okay, na? So that's where we have the valence shell electron pair repulsion theory. Fine. Okay. Now next one here is, it is related to the postulates of VSEPR theory. This is a bit important. Postulates of VSEPR theory. The postulates of VSEPR theory. So this one they will ask. Okay. So postulates they will ask. Now when I am talking about VSEPR theory, that's what it talks about. It talks about the shape of the molecules. It deals with the shape of the molecules. Okay. So it deals with the shape of the molecules. First postulate related to VSEPR theory. The first postulate, it tells that shape of the molecule, shape of the given molecule depends on number of bonded and non-bonded electrons. Number of bonded and non-bonded electrons. So shape of the given molecule will be decided by what? It will be decided by depending on number of bonded and non-bonded electrons. All of you have understood? That is because in the name itself it is there, valence shell. So what do you mean by valence shell? Outermost shell. When I am talking about a molecule, so we have to consider outermost shell of those elements which are involved in the interaction. I should consider outermost shell of those elements which are involved in the interaction, because there will be overlapping of those shell will take place during the bond formation. If you recollect, according to Lewis dot structure, if I consider this one as a water, right? So there will be electrons like this. Now if I consider this one as a 2 electron, so Lewis dot structure will be written like this. If you observe, there is a overlapping of the orbital is taking place. There is a overlapping of orbital is taking place. That is outermost orbital, valence orbital. So that's what valence shell, electron pair, repulsion theory. Because electrons negatively charged. When one electron will come near to the another electron, naturally there should be a repulsion. Naturally there will be a repulsion. All of you got my point? But when I am talking about an orbital where two electrons will be occupying the same orbital, there is a different story where electron will be having opposite spin. Electrons will be having opposite spin, clockwise, anti-clockwise, if you remember. So that's why in a particular orbital, two electrons will be paired up. You might be having a question, sir, why not repulsion there? That is because of the opposite spin. Okay? So that's why a particular orbital can accommodate two electrons. Right? But when I am talking about shape of the molecule, naturally we have to consider the repulsions which will be happening between these lone pair electrons and the repulsion which is happening between bonded pair and bonded pair electron. If I consider here, so there will be a repulsion between lone pair electron, and there will be a repulsion between bonded pair electron. And there can also be a repulsion between lone pair bonded pair electrons, because electrons are having negative charge, and negative same charge, therefore they will be repelling each other. Okay, all of you have understood? So that's what it tells. Fine. Any doubts? Any doubts? Okay. So ಹಾಗಾದ್ರೆ next one. With respect to lone pair of electrons. So lone pair of electrons, pairs of electrons will occupy this space where they will be far from each other. They will be far from each other. They want to have the space, or they will occupy the region in the space where they will be far from each other. Why? Because there is a repulsion. Because they are free electrons. They are not involved in the bond formation. Therefore, there will be a repulsion. So they want to stay far from each other. So what I mean to tell you is, valence shell considered as a sphere, valence shell considered as a spherical sphere, where electrons will be far from each other, Okay, na? That's what it tells. That's what it talks about. All of you have understood? That means they should have the maximum space between them, or they should be at maximum distance from each other. So that's what it talks about. Okay? ಹಾಗಾದ್ರೆ when I am talking about multiple bonds, when there will be presence of a multiple bonds, that means I am talking about double and triple bond. Double and triple bonds. When I am talking about multiple bonds, those bonds will not be considered as a double or triple in VSEPR theory. It will be considered as a single bond. Will be treated as a single bond. So what I mean to tell here is, in a single bond 2 electrons are involved. In a double bond 4 electrons are involved. In a triple bond 6 electrons are involved. But during the VSEPR theory, during the shape of the molecule, these electrons number will not be considered. Altogether they will be considered as bonded pair of electrons. So no confusion, right? The last statement which talks about multiple bonds, where double or triple bonds will be treated as a single bond. That means with respect to single bond, how many electrons will be there? 2 electrons. With respect to double bond, how many electrons will be there? 4 electrons. And with respect to triple bond, there will be 6 electrons. So number of electrons, yes, it is getting increased. But with respect to shape of the molecule, in VSEPR theory, they will consider them as a single bond. They are not going to talk about, or they are not going to consider the number of electrons. Okay? So that's what the last statement talks about, whatever I have written. That's what the last statement talks about. Any doubts? So these postulates, now the last one is there. Last one. So what is VSEPR theory? VSEPR theory talks about the shape of the molecules. Okay? So that's what the first statement. Shape of the molecule will be decided by, number of lone pair and bonded pair of electrons. Okay? When I am talking about the repulsion, it will be high with respect to lone pair repulsion. It will be high compared to lone pair bonded pair repulsion. It will be high compared to lone pair bonded pair repulsion. Now it will be high compared to bonded pair repulsion. So what I mean to tell here is, this one you have to mention along with the postulates at the end. So what I mean to tell here is, according to VSEPR theory, lone pair of electrons, when they come near to each other, they will have more repulsion compared to when lone pair of electron, they come near to bonded pairs of electron. There will be a repulsion, but it will be less compared to first one. Now bonded pair electron, when they come near to each other, naturally there will be a repulsion, but it will be much less compared to lone pair repulsion, and it will be less compared to lone pair bonded pair electron repulsion. All of you have understood? So this particular thing you have to mention at the end of VSEPR theory postulates. Fine? All of you have understood? Shall we take some of the example with respect to the shape of the molecules? So due to that, when I am talking about the molecules, according to VSEPR theory, they will classify the elements into 2 categories. One is without lone pair of electrons. One type of compound will be without any lone pairs of electron, and another one will be with lone pairs of electron. So we can have in the nature 2 types of compound based on VSEPR theory. One category is where there will be no lone pairs of electron left over. And another category where there will be lone pair of electron will be present. That's where we can have the two category of elements. All of you have understood? Any doubts? Okay. So I will take the example from your textbook only. See, for example, if I take first one without lone pairs of electrons. If I take the first category without any lone pairs of electron, I can give the example of beryllium chloride. I can give the example of beryllium chloride. This is example 1. Beryllium belongs to which particular group? Any one of you? It belongs to alkaline earth metal. Beryllium belongs to alkaline earth metals. That is group number 2. What is the total valence electron in beryllium? Anyone? What is the total number of valence electron? What are the total number of valence electrons in beryllium left over? Or means total valence electron. You can just mention the number. Yes, Rohan. It's the alkaline earth metal, first element. So what is the total number of valence electron present in the beryllium? Suchita, she is writing 3. Beryllium, alkaline earth metal. Suchita madam, I told it is. Okay, Pooja, she is writing 3. Okay. Pooja madam, Suchita has deleted her answer. Rohan is telling 1. Oh, Dhanush is telling 7. No, pa. It's not 3, no 1, it should be 2. Chidvan is correct. Now Suchita, she has made it correct. Okay, it is 2. Okay? It is 2, not 7 and all. Since it belongs to group number 2, it should have the total valence electron 2. In that case, if I take beryllium chloride, that's why I have the Lewis symbol for beryllium. Lewis symbol for beryllium. Now, it is attached with 2 chlorine atom. It will be attached with 2 chlorine atom. So that's where I have 1 chlorine. That's where I have another chlorine. So that's where we have the beryllium chloride. So which will be having like this. Now, all of us we know that in beryllium chloride, I am talking about central atom, that is beryllium. In beryllium chloride, beryllium, a central element, does not have any lone pair of electrons. Don't get confused. I am not talking about the chlorine. Chlorine will be having lone pairs of electrons, no doubt. But beryllium is a central atom. 2 beryllium, 2 chlorines are attached. So beryllium will be considered as a central atom. So in beryllium, any lone electrons will be left over? No. 2 valence electrons, and both the valence electrons are utilized in making the bond with the 2 chlorine atom. So there is no lone pairs of electron. So therefore, they will be having a structure where this one will be having 180 degree. It will be having 180 degree. That is the maximum distance which can be attained by the 2 bonds, beryllium chlorine bonds. It is the maximum distance they can occupy. That's what VSEPR theory talks about, right? So that's what this shape will be called as. Shape in the sense, this can be called as linear structure. This can be called as a linear structure. Fine? All of you have understood? Okay? So, another example I will take. Example 2. Same category, without lone pairs of electron. Example 2. This molecule also we have discussed. Boron trifluoride. Boron trifluoride. Boron belongs to group 13, 1, 3. What is the total valence electron in boron then? Any one of you? Boron. People might have got confused that time. Beryllium and boron. Yes, Shuchita, you are absolutely correct. It will be having 3 valence electron. Boron belongs to group 13. It will have 3 valence electron. Okay? So yes, you people are correct. So then that's where I have got the Lewis dot structure for the boron. That's where we have got the Lewis dot structure for the boron. Yes, all of you right. It is having 3 valence electron. Now it will make the bonding with 3 fluorine. It will make the bonding with 3 fluorine. So that's where fluorine, fluorine and fluorine. Now, if you observe this molecule, any lone electron is left over with boron. Boron is a central metal element in this molecule. All of you will agree? Right? In this compound, in BF3, boron will be a central atom. Okay? So whether boron is left over with any lone pair of electrons? No. Because it is having 3 valence electron and all the 3 valence electron has been utilized in the making the bond with the 3 fluorine. So therefore, boron trifluoride, boron does not have any of the lone pairs of electron. So please, I am not talking about fluorine. I am focusing on central atom only, that is boron. What do you mean by central atom in a compound? Central atoms are those to which all the other elements are making bond. Okay? So that's why boron does not have any lone pair of electrons. So therefore, this will be the maximum distance between bonded pair and bonded pair electrons, where they are having 120 degree bond angle. Okay? Where they are having 120 degree as their bond angle. And this particular shape is called as trigonal planar structure. Trigonal planar structure. Where it is having trigonal planar structure. All of you have understood? So that's where beryllium chloride BeCl2 is forming linear structure because only 2 valence electron in beryllium. In boron trifluoride it is forming trigonal planar structure because 3 valence electron in the boron. All of you have understood? Okay. So next one. Another example. Example 3. If I take methane, a very common molecule you are going to study in organic chemistry. That is methane. Where carbon, how many valence electrons in the carbon? Any one of you? How many valence electrons in carbon? How many valence? Yes, very good. All of you right. It will be 4 valence electron. That's where Lewis symbol. I can mention it as Lewis symbol for the carbon. Now it is making the bond with the hydrogen. How many hydrogen? 4 hydrogen. Okay. Now, please remember that it looks like it's a planar structure. Many students, they will get confused. They think that it is a tetragonal planar structure. Trigonal planar, same way, tetragonal planar structure. But if I take tetragonal planar structure, the bond angle will become less, 90 degree. So it will become 90 degree between this. But according to BSEPR theory, they should be far from each other. Bonded pair electrons, they should be far from each other. So therefore, it is not a tetragonal. It is not a tetragonal planar structure. No. Since I cannot represent the 3D structure, that's why I have simply written like this. In reality, it is bonded with the 3 hydrogen. It is bonded with the 3 hydrogen, where 1 hydrogen will be behind the plane. where one hydrogen will be behind the plane, behind the boat. Okay, so they are facing away from us. All of you have understood? So that's where we have the bond angle, not 90 degree. Now the bond angle is 109.5 degree. If it is planar structure, it would have been 90. Now it will be 109.5 degree. So which is called as tetrahedral structure. This is nothing but a tetrahedral structure, a 3D structure. Planar means 2D structure, but tetrahedral is a 3D structure. Linear, a 2D structure. When I am talking about trigonal planar, it is a 2D structure, but here it is a 3D structure, tetrahedral. That means 4 faces containing structure. 4 face it will be there. Therefore, it is called as tetrahedral. All of you have understood? Any doubts? Okay, that's where we have the methane, one of the common example for a molecule with a tetrahedral structure, where carbon does not have any lone pair of electron. Why I am talking about carbon? Because carbon is a central atom in methane. Fine. Now we will come to example 4. That is PCl5. So that is PCl5, phosphorus pentachloride. I am taking the examples from your textbook only. Please remember. So phosphorus belongs to group 15, 1,5. So how many valence electron in phosphorus? Anyone? How many valence electrons should be there in phosphorus? It belongs to group 15. How many valence electrons should be there? Yes, all of you correct. It should have the 5 valence electrons. Phosphorus is a central atom in PCl5. So 1, 2, 3, 4, 5. So this is where I have the Lewis symbol for the PCl5. Means phosphorus, not PCl5, phosphorus. Now, all of us we know that these electrons should be far from each other according to VSEPR theory, right? Because in this PCl5, no lone pair of electron left over. All the 5 electrons of phosphorus, they are involved in the bond formation. So that's where chlorine, that's where chlorine, that's where chlorine, that's where chlorine, and that's where chlorine. Right? All the 5 electrons are involved in the bond formation. Now they want to stay away from each other as far as possible. They want to stay away from each other. That's where what PCl5 will do here is it will have 3 chlorine in one plane. 3 chlorine in one plane. And rest of the 2 chlorine, it will be in another plane. All of you have got understood? So these 3 are in one plane, that is trigonal structure. Trigonal structure. Okay, they will be present in one plane. Naturally, the distance between this one will be, means bond angle will be 120 degree. It will be 120 degree. And these 2 chlorine, one is above and one is below. So therefore, they will be forming 90 degree. They will be forming 90 degree. So that's where we have the one of the structure with respect to PCl5, where 3 chlorine will be in one plane and 2 chlorine, one will be above the plane and another one will be below the plane. In the sense, if I take this paper as one plane, okay, this paper as one plane, in this paper 3 chlorines are present. In this paper 3 chlorines are present. Okay, by considering this one as a one plane, 1, 2, 3, 3 chlorines are present, and 1 chlorine will be above and 1 chlorine will be below. So that's what above the plane, below the plane means. Okay, it will be like this. So black cap is above the plane and white one, it is below the plane. All of you have understood? It is like this. So that's what it will happen in PCl5. Okay? Now, if you see here, if I join edges of these, if I join the edges of these, it looks like pyramid. It looks like a pyramid. All of you can see, it looks like a pyramid. So one chlorine, another chlorine, another chlorine, and here another chlorine. So it looks like pyramid with the base of trigonal. With the base of trigonal. All of you have understanding? With the base of trigonal. So that's what two tips are there. One is here, okay, and another one is here. So therefore there will be presence of two tips. So therefore it is called as a trigonal bipyramid. Above one pyramid, below one pyramid. So it will be trigonal bipyramid structure. It will be having trigonal bipyramidal structure. PCl5. No lone pair of electron with respect to phosphorus. It will form trigonal bipyramid. Why bipyramid? Two pyramids which are attached to each other like this. Okay? So with the plane of trigonal plane. So therefore it is called as trigonal bipyramid structure. Speciality here is this is called as axial bonds. They are called as axial bonds. These two. Okay? They are called as axial bonds which are above and below the plane. And these three bonds are called as equatorial bonds. They are called as equatorial bonds. Now please remember in PCl5 all the bond lengths will not be same. Equatorial bonds it will be of one length and axial bonds will be of one length. Where axial bonds will be a bit longer compared to equatorial bonds. All of you have understood? Please remember this. In PCl5 all the bonds are not same. Whatever axial bonds are there, to make you understand I am writing here. Okay? Whatever axial bonds are there, it will be of longer compared to equatorial bonds. Got my point? That is PCl5. That is with respect to PCl5. Okay? Now this is another example. Now the last one will be SF6, Sulfur Hexafluoride. Last one will be Sulfur Hexafluoride, SF6. Okay? Now when I am talking about SF6, please remember any element where one atom is attached with 6 other atoms without lone pair of electron, then it is called it will going to form octahedral structure. It is a structure where 6 bonds will be there and it is going to have the shape which will be having 8 faces. Which will be having 8 faces. That's where octahedral structure. So please once again remember any compound where central atom does not have any lone pair of electron and it is bonded with 6 fluorine. Now those type of compound is going to form octahedral structure with 90 degree of bond angles between them. With 90 degree of the bond angles present between them. All of you have understood? So this is one category without any lone pairs of electron. Okay? Any doubts? Okay? Now if I take the water, now I will come to second category with lone pairs of electron. If I take the water, now here in case of the water, central atom is oxygen, right? Now there will be presence of 2 lone pairs of electrons. Okay? So that means lone pair repulsion, since it is there, it should make far. They should be much far from each other. and this bonded pair and lone pair, there will be repulsion which will be bit less compared to this, and this repulsion will be much more less. So therefore they are going to form the bent structure. They are going to form the bent structure where the bond angle will be 104.5 degree. Why bond angle is 104.5 degree? That is because of the lone pair repulsions. So due to that, for example, this would have been the water molecule. These two can be the hydrogen. Since there is a lone, if you consider my ears as lone pairs of electron, now my hands as the bond, they want to stay away from the lone pairs. So instead of like this, they will become like this. Because the repulsion between these two, it will be less compared to these two. Right? So therefore, instead of like this, it will become a bent structure. So that's where water molecule will have the bent structure due to the repulsion of lone pair electrons, and the bond angle will be 104.5 degree. Therefore, water will be having dipolarity. Water will be having dipolarity. All of you have understood? So water will be having dipolarity. Same way, we have another molecule, SF4, sulfur tetrafluoride. We have another one which is called as sulfur tetrafluoride. So sulfur, whether any lone pairs of electron with sulfur, whether sulfur will have any lone pairs of electron? Yes, sulfur will have one lone pair of electron because only 4 bonds will be there. Sulfur will be having 6 valence electron. In that only 4 has been utilized. 2 will be left over as it is. So therefore, there will be presence of fluorine like this. Okay? So that means whatever orbital which is due to lone pair, they will be present in one plane, because lone pair, they want to stay away from all the bonded pairs. They want to stay away from all the bonded pairs. They will be one side, and all the other bonded pairs, they will be on the other side. All the bonded pair they will be on the other side. Therefore, this structure, it looks like seesaw structure. It looks like a seesaw structure. Seesaw means it is the game. It's an instrument which will be present in the park, where one kid will be sitting here, another kid will be sitting here. In the center, there will be a support, and it will become like this. Right? So all of us, we have played this one. So that is called as seesaw structure. And sulfur tetrafluoride can form the seesaw structure due to the presence of lone pair of electrons. Okay? But when it comes to ammonia, now also there will be presence of one lone pair of electron. But it's going to form trigonal pyramidal structure. It's going to form trigonal pyramidal structure like this. Okay, na? So that's where we have the trigonal pyramidal structure. It's not planar, it's a pyramidal 3D structure. Ammonia is going to form trigonal pyramidal structure. Why? Here also lone pair of electron, here also lone pair of electron. Then why different structure? That is because difference in the bonded pairs. Therefore, they will have the different structures. All of you have understood? So these are some of the examples related to compounds with the presence of lone pairs of electrons. Okay, with the presence of lone pairs of electrons. Any doubts in this? This is with respect to VSEPR theory. Postulates you can expect. and I have told how the shape of the molecule is going to affect the polarity, dipole moment of the molecule, right? So try to practice with more examples which is there in your textbooks. Any doubts, without hesitation you can call me, no problem. Okay? You can go through your check sheet also, you can go through your textbook also. And all the best, do well in your exams. Fine? Thank you. In that case, I will stop here. Thank you. Thank you very much. Take care. So we will meet in next week. Fine? Thank you. Thank you. All the best.